Hey everyone, so welcome to a science news segment. As you can tell, I'm doing things a little differently this time. It's not just audio only, there's going to be a video component to this science news. Hopefully you enjoy this, hopefully this works out well, and we might see more of this in the future if I like it. Okay, so I want to cover I want to cover a few science news stories today about life in space in various forms. There have been a few really interesting, really cool articles that have come out lately, and I just wanted to touch on some of them. So this first one that we can see is a press release from the NASA's Mars exploration program. Curiosity finds a Martian flower. Interesting. So every now and then, a rover on Mars will image a rock or a sand formation or something that looks peculiar. NASA scientists will usually be quick to diagnose such anomalies as just weirdly shaped minerals or a camera artifact or some kind of benign technical detail like that. But of course you have amateur enthusiasts on the internet who can see these images too, and they tend to be, let's say, a bit more creative with their interpretive hypotheses. Now I bring this up because this is a very unique object and it's inspired a lot of really frenzied discussion, and Curiosity is also in a really interesting place. The Curiosity rover is exploring Gale Crater on Mars, which used to be a very wet place in Mars's ancient past, and so NASA thinks it might be a good place to find life, fossils of life, chemical residues of life, any kind of evidence at all, whatever form it takes. Now, if we look at the image here, we can see this so-called Martian flower. The image appears to show, this strange object. It's the same color as the background sand, but it looks like a rock that was almost flash frozen in the act of blowing up. It also looks kind of like a piece of small coral or some kind of primitive flower. Now, nearby in this picture, we can also see some small rocks. And at first glance, they kind of look like unexploded versions of this Martian flower. Now, the more salacious interpretations from internet commenters suggest that this is an alien organism. It's some kind of Martian plant or fungus. Or maybe it's an alien animal that looks like coral, or perhaps it's some kind of colony organism. It seems like a lot of these people skipped over the part where we first have to determine if this is life or not, and they just went right to talking about what kind of life it is. Now, you guys know me. There's no one in the world who wants alien life to be real more than me. Like, even microbes. I freak out over microbes. Remember when we almost found microbes in the atmosphere of Venus? That was the coolest thing. That was the coolest story I think I had heard all year. Well, complex organisms like this on Mars would be absolutely mind-blowing. It'd be world-changing. But before we speculate about what kind of life this is, we have to take a step back and determine if this is actually life or not. And NASA, all the experts over there who, are behind the hardware and software that took this image, none of those people think that this is life. In a press release that we can see here on this finding, NASA has described this artifact as smaller than a penny. So it's really tiny, and they claimed that it was, quote, made in the ancient past, when minerals carried by water cemented the rock. Here's a close-up image of it. If we'll load, I guess we're not going to load. Oh, well. Figure A. Interesting. This UI is strange. Anyway, so they think it was some kind of mineral that can only form in the presence of water. And that's interesting in its own right, because it means that when this mineral formed, this was a wet environment. It means that Mars at one point had liquid water. This is more evidence corroborating that increasingly popular hypothesis. I should say a theory, because it's pretty well established at this point. There's pretty clear evidence of like river deltas and stuff on Mars. So, now if you follow this kind of stuff, if you pay attention to weird images of things that NASA photographs on other planets, You might remember the so-called Martian blueberries, which was another photograph of some mineral formation discovered in 2004. Now, this situation here, the Martian flower, is almost exactly the same. In 2004, with the Martian blueberries, a NASA rover took some pictures of these like bulbous globular minerals, and a bunch of amateurs claimed that it was some kind of organism, like an insect with a really bulbous abdomen, or a vegetable that produced berries, or some kind of bryophyte-like nodule, or maybe a fungal structure or something. But of course, it wasn't any of these. It wasn't any of these things at all. It wasn't life. It was just a mineral that forms in the presence of liquid water. Now, like I said, this is fascinating in its own right because it tells about an ancient Mars that was wet with oceans and hydrological systems and water-dependent geochemistry. This is a Mars that very well may have hosted life, and learning about the ancient environment through these minerals can give us clues to to any of this potential ancient life if it existed. These are just clues on the path to finding ancient Martian life. But this is still very interesting. Even as a mineral, it looks super cool. And it's still kind of mysterious. NASA hasn't yet confirmed its chemical composition. There's some speculation that this Martian flower might be a form of fulgurite, which is a mineral created when lightning strikes rock. Or in this case, it would be sand, and it fuses it like glass. But no matter who you ask, no reputable scientist is going to claim that this is life. But it's still interesting. Okay, let's go into the next story here. The case and context for atmospheric methane as an exoplanet biosignature. All right, this is a really important study. It's super well timed too. We'll get into that, and it's also a good opportunity for me to own up to a mistake I made in the recent past. Okay, so before we get to that, let's dig into the significance here. So the significance in the abstract. Okay, so the significance of this paper, of this research, quote, astronomers will soon begin searching for biosignatures, atmospheric gases or surface features produced by life on potentially habitable planets. Since methane is the only biosignature that the James Webb Space Telescope could readily detect in terrestrial atmospheres, it is imperative to understand methane biosignatures to contextualize these upcoming observations. Okay, pause here for a second. So in the past, I have stated that the James Webb Space Telescope can take spectroscopic analyses of exoplanet atmospheres and identify oxygen as a potential biosignature, like free molecular oxygen in the atmosphere. This is not accurate. I was incorrect about that. The James Webb actually can't detect oxygen. I don't fully understand the technical details, but to the best of my knowledge, the spectroscopic signature of oxygen is relatively subtle. And James Webb although it's extremely sensitive, it doesn't have the sensitivity required to positively identify oxygen within the exoplanet atmospheric spectroscopic signals that it's going to be analyzing in the first place. It's already a pretty small amount of light, just a sliver of light reflected through an atmosphere. And it's really tricky, I guess, to identify oxygen in that, and this James Webb can't do it. Which is a total bummer, because oxygen is like the best biosignature there is. But methane is also a potentially useful biosignature, and James Webb can detect that. So let's get back into it and see why is this important. So they say, quote, we explore the necessary planetary context for methane to be a persuasive biosignature and assess whether and in what planetary environments abiotic sources of methane could result in false positive scenarios. With these results, we provide a tentative framework for assessing methane biosignatures. If life is abundant in the universe, then with the correct planetary context, atmospheric methane may be the first detectable indication of life beyond Earth. Okay, so that's super fascinating. What they're basically saying is methane can be produced, by both abiotic and biotic processes, and to determine if any observed methane on these exoplanets is biotic in origin, we need to understand some of the larger planetary geochemical context that methane could exist within. And depending on what that context is, if we see methane, and then compare it to all these other variables, if they all match in this one context, well, that means, okay, it's probably abiotic. It could be volcanoes. But if it's another context, if there's other variables, then we could conclude, hey, this is very likely to be a biological signature. And so this is a really important paper because it's telling us basically they're troubleshooting, trying to find flaws in these detection scenarios to minimize the risk of false positives or false negatives. And this is super valuable because the James Webb has deployed like yesterday. Like it's up there right now in the Lagrange point, like going through all its diagnostic tests and getting ready to start taking actual measurements. And as far as I know, those measurements could begin any day now, which is super exciting. Okay, so let's look at the abstract, which kind of explores their specific research in a bit more detail. Okay, so the abstract says, quote, methane has been proposed as an exoplanet biosignature. Imminent observations with the James Webb Space Telescope may enable methane detections on potentially habitable exoplanets. So it is essential to assess in what planetary contexts methane is a compelling biosignature. Methane's short photochemical lifetime in terrestrial planet atmospheres implies that abundant methane requires large replenishment fluxes. While methane can be produced by a variety of abiotic mechanisms such as outgassing, serpentinizing reactions, and impacts, we argue that, in contrast to an Earth-like biosphere, known abiotic processes cannot easily generate atmospheres rich in methane and carbon dioxide with limited carbon monoxide due to the strong redox disequilibrium between methane and carbon dioxide. Methane is thus more likely to be biogenic for planets with 1. A terrestrial bulk density, high mean molecular weight, and anoxic atmosphere, and an old host star. 2. An abundance of methane that implies surface fluxes exceeding what could be supplied by abiotic processes. And 3. Atmospheric CO2 with comparatively little CO, carbon monoxide, unquote. Okay, so you can find the whole paper here. Like we could go through the whole thing, but it's a little chemistry heavy. And I'll admit that my chemistry knowledge is really not very strong. A lot of this stuff is, even these relatively simple looking equations, I understand the bare basics of it. But if we were to dig into the details of it, volcanic hydrogen flux. Yeah, this stuff starts to go beyond me really fast. But they do have this interesting, okay, here we go. Here's an interesting little graph of abiotic sources of methane. Source of reducing power. Okay. So this is like iron that reduces the methane. Volcanoes can outgas it. Continental settings can apparently produce it. The metamorphic and water rock reactions and Precambrian shields and ophiolites. Comets and asteroid impacts. Hydrothermal systems like water rock reactions at deep sea vents and mid-ocean ridges. And of course, subduction zones. Oh, all right, fascinating. All these things can produce methane abiotically. And then, of course, biotic methane generation comes from the appropriately named methanogens. But interestingly, methanogens, they can't exist in oxic conditions. The presence of molecular oxygen interferes with the enzymes involved in methanogenesis, and it disrupts the process. And it actually kills those methanogenic microbes. So that's really interesting. So let's go back to these 3 points that they concluded here. I want to explore these a little bit more. So they say that methane is most likely to be a biogenic signature, or biosignature, on planets that have. So this first point is saying an old host star, and it's my understanding that this means like a star that's stable, that's been around for a while. It's not giving off like high X-rays or UV radiation that you often see in more unstable younger stars. Perhaps this is also like a proxy by which the planet could also itself be old, and so you have a long evolutionary period to work with here. They talk about a high mean molecular weight atmosphere. That means the atmosphere is composed of molecules that are relatively large, relatively heavy, not small molecules, which I don't know, depends on how you define it, but CO2 could arguably be a high molecular weight molecule. That oxygen's pretty heavy, and you got 2 carbons there too. Certainly heavier than water. CO2. 2 oxygens, which are heavy, and a carbon as well. Water vapor, like if you had water in the atmosphere, that's going to be a fair bit lighter. just one oxygen and two hydrogens. And of course, oxygen itself, molecular oxygen too, is going to be a bit lighter than CO2. Nitrogen is going to be a bit lighter still. I don't have a table of elements in front of me, but this is beside the point. The key detail here is the anoxic atmosphere. We're not going to find methanogenic life forms on a planet that has a bunch of oxygen in the atmosphere, because that oxygen is going to kill them. It's going to disrupt that process, disrupt these energetically favorable chemical pathways that process methane. So it has to be anoxic. And what this means is that any life we find is probably not going to be very similar to us. It's going to be more similar to terrestrial methanogens, which, because they can't tolerate oxygen in the modern world that we live in today here on Earth, methanogens tend to live in anoxic environments, like in the mud, in caves, underwater. And they're not very widespread. They used to dominate the world, but the great oxygenation event pretty much wiped them all out and changed the entire ecology of the surface of our planet. But it's another story for another day. Point number 2. An abundance of methane that implies surface fluxes exceeding what could be supplied by abiotic processes. Okay, so if we go back to all this picture here that shows all of these abiotic processes that could produce methane, all of these different chemical reactions not involving life. If all of these combined can't explain the amount of methane that we observe in the atmosphere, that really only leaves, the biotic explanation remaining. Like there has to be some other thing that makes up the difference. And if none of these comets and asteroid impacts and volcanic activity and deep ocean vents and ridges, if none of this stuff all cumulatively can explain the total methane in the atmosphere, the biotic explanation comes in to fill in the difference. And so this is why, in this situation, methane would be a very potent biosignature. And then the third point here is that you would also want to see atmospheric carbon dioxide, the presence thereof, with relatively little carbon monoxide. Now, I think this is kind of getting into that chemistry territory that I don't fully understand. But it seems to be that if there's a lot of carbon monoxide, that would suggest that perhaps whatever geochemical processes are involved to produce all this carbon monoxide is not producing methane, or is disrupting the production of methane. I'm not entirely sure, can't say with certainty, but this is what they concluded. So, anoxic atmosphere, more methane than can be explained with abiotic processes, and relatively high CO2 compared to CO. Now, there's this fascinating article in Eureka Alert about this research, and I just want to go over this a bit with you because it's pretty cool. It's pretty interesting. So first things first, they say that methane could be the first detectable indication of life beyond Earth. All right, so that's super cool. So this research was done at UC Santa Cruz, and if we go back to the paper here, Maggie Thompson is a graduate student who did the research, who led the research. He's the lead author here. And then Joshua Chrysanson Toten is a co-author. I will get some quotes from them in the article here. So kind of explaining the background information here, kind of what I covered just a few minutes ago. Maggie Thompson said, quote, "Oxygen is often talked about as one of the best biosignatures, but it's probably going to be hard to detect with James Webb Space Telescope," unquote. And so, that's a very legit point. And so because probably not going to be able to use oxygen, they wanted to check out methane. She said, quote, "We wanted to provide a framework for interpreting observations. So if we see a rocky planet with methane, we know what other observations are needed for it to be a persuasive biosignature." It's a really good argument. This is a really good point. And again, I'm super, super happy that research like this is coming out when it's coming out. I mean, it couldn't be timelier, Okay, so co-author Joshua Chrysanson Toten said, "If you detect a lot of methane on a rocky planet, you typically need a massive source to explain that. We know biological activity creates large amounts of methane on Earth, and probably did on the early Earth as well, because making methane is a fairly easy thing to do metabolically," unquote. Now that's a really interesting point that I actually want to expand on for a second. Producing methane metabolically through these energetically favorable biochemical pathways, that's really important. Because if we're talking about like planets that might be habitable, in the Goldilocks zone of their star system elsewhere in the cosmos, in the galaxy, if this methanogenic biochemical system is pretty simple, that suggests it's might be relatively easy to evolve. It might be one of the first energy harvesting biochemical processes that are evolved through chemical evolution on the pathway to creating true life forms. And so it's possible that these alien microbes, if they're out there, if we discover them, they originated as some kind of, proto-living chemical evolutionary process that produced, this methanogenic system where energy is shared back and forth between enzymes and pigments or whatever. And the end result is the production of methane. Super fascinating stuff. Definitely feasible too. And if it's relatively easy to do that metabolically, then we might expect to see like primitive methanogenic biochemistry on these like young or anoxic habitable worlds throughout the galaxy. That could be super awesome. I mean, hey, I think it's entirely possible that methanogenic microbial activity might be much more common throughout the galaxy than we think. All right, but this is a tangent. Let's get back to the article. So the study, they say, emphasizes the need to consider the full planetary context in evaluating potential biosignatures. The researchers concluded that for a rocky planet orbiting a sun-like star, atmospheric methane is more likely to be considered a strong indication of life if the atmosphere also has carbon dioxide. Methane is more abundant than carbon monoxide, and extremely water-rich planetary compositions can be ruled out. Okay, so you want to rule out water-rich compositions, generally because that means you're going to have a lot of water vapor in the air, and there's going to be a lot of oxygen involved in reactions, geochemical reactions on the surface and in the atmosphere. And like we talked about earlier, that's a little bit difficult for methanogenic life to deal with. So Maggie Thompson explains a bit more. She says, one molecule is not going to give you the answer. You have to take into account the planet's full context. Methane is one piece of the puzzle, but to determine if there is life on a planet, you have to consider its geochemistry, how it's interacting with its star, and the many processes that can affect a planet's atmosphere on geologic timescales. And so the study considers a variety of possibilities for false positives, provides guidelines for assessing methane biosignatures. Chrysanthemum Toten is explaining that there's two things that could go wrong. You could misinterpret something as a biosignature and get a false positive, or you could overlook something that's a real biosignature. He said, quote, with this paper, we wanted to develop a framework to help avoid both of those potential errors with methane. Very interesting stuff. So he also added here at the end, this study is focused on the most obvious false positives for methane as a biosignature. The atmospheres of rocky planets are probably going to surprise us, and we will need to be cautious in our interpretations. Future work should try to anticipate and quantify more unusual mechanisms for non-biological methane production. All right, so this is really cool stuff. It's super important because if we know what false positives to be wary of, then it'll only refine our search for life. It'll only refine our ability to positively identify methane as a biosignature. This is awesome. It's only good news, and like I said, it couldn't be more well timed. The James Webb Space Telescope is coming online as we speak. It could start bringing back like actual photographs any day now. And honestly, I'm willing to bet that maybe in the next couple of years, maybe this year, we're probably going to see headlines and articles discussing the alien life discovered through detection of a methane biosignature by the James Webb Space Telescope. That's going to be an amazing day. I really can't wait for that. And it's all coming into focus. It's so exciting. Okay, so that was our second news article. Let's go to our last news article for today. The case for space sexology. So this is also known as the space sexology proposal. This is a really interesting topic, and I didn't understand how little we knew about it and how actually critically dangerous this lack of knowledge is for all of human advancement into space. So this is actually a really big deal. Let's go through the abstract, and then I'm also going to read you an article that was written about it, and you'll get the whole picture. So first things first, notice that this article was published last year, near the end of 2021. So the news about this isn't so much that this article was published. The news that I want to bring you is about the response to this article, the response to this whole movement in the sciences within like NASA and SpaceX and all these private space companies and stuff. Okay, but we're getting ahead of myself. Let's get into this abstract first. So the abstract here for this space sexology proposal, quote, "Space poses significant challenges for human intimacy and sexuality. Life in space habitats during long-term travel, exploration, or settlement may detrimentally impact the sexual and reproductive functions of astronauts, restrict privacy and access to intimate partners, impose hygiene protocols and abstinence policies, and heighten risks of interpersonal conflicts and sexual violence. Together, this may jeopardize the health and well-being of space inhabitants, crew performance, and mission success. Yet little attention has been given to the sexological issues of human life in space. This situation is untenable considering our upcoming space missions and expansion. It is time for space organizations to embrace a new discipline, space sexology, the scientific study of extraterrestrial intimacy and sexuality. To make this case, we draw attention to the lack of research on space intimacy and sexuality, discuss the risks and benefits of extraterrestrial eroticism, and propose an initial biopsychosocial framework to envision a broad collaborative scientific agenda on space sexology. We also underline key anticipated challenges faced by this innovative field and suggest paths to solutions. We conclude that space programs and exploration require a new perspective, one that holistically addresses the intimate and sexual needs of humans in our pursuit of a spacefaring civilization." Acknowledgements. Yeah, so very interesting stuff. The gist of it is that as we go into space, we're necessarily going to be spending longer periods of time, in orbit, in transit. If we have permanent colonies on the moon or on Mars, obviously people are going to be living there for a long time. And whenever you have people in close proximity to each other for long periods of time, they're going to develop relationships. They're going to come to like each other, maybe. And they might even want to have sex. And if there's rules against that, like abstinence policies, or if the logistics of the spaceship or the colony don't facilitate, this kind of social culmination in the sexual relationship, that can lead to conflict and suboptimal crew performance. And this is actually a very real risk that we need to start taking seriously as we engage in these bigger crews, like missions with bigger crews, longer missions, where they're in a confined space for longer periods of time. As we start to set up, manned bases on the moon and Mars, which is all part of Project Artemis. We'll get to this, but it's all in the works. All of this stuff is being planned. And so we can't ignore this issue. And that's the case that's being made here. So the news that I want to bring you, basically, is very nicely explained in this article from the BDG's Mike. It's written by an author, Mark Hay, and it includes a bunch of quotes from various experts, and it explores kind of the history of space agencies with regards to studying sex in space. And so I want to go through this article. We'll get a brief rundown of the history of this, where we're going, why it's important to learn more about sex in space, all aspects of sex in space, not just the social aspects of it and the romantic aspects of it, but also the physiological, the anatomical, the developmental aspects of it. Like when you're going into space, you're exposed to a lot of radiation. How does that affect your germ cells? How does that affect your gametes? How does that affect any embryos if there's fertilization? How does this affect, offspring, children? Are there teratogenic effects? Does this have, developmental issues, life in space, exposed to microgravity and radiation and, all this stuff? The short answer, we'll get into this, is that we don't know. And this lack of knowledge is actually really dangerous, and it poses a lot of risk. Okay, so this article, Inside the Push to Study Sex in Space. We don't know pretty much anything about sex in space, but it's been a topic of curiosity for a really long time. I mean, it's in science fiction. going back to like the 50s and 60s, when I'm summarizing this article while I'm trying to get into it, and let's just get into the article. Okay. So first of all, they established that everyone wants to go into space and set up colonies. Like Elon Musk wants to go to Mars by 2050. NASA has projects to colonize the moon and Mars. But no one's really studying sex in space. It hasn't been a major part of these research programs, even though researchers have been pushing this for at least 30 years. So it's not like they're not aware that this is an issue. People have been saying, hey, we need to study this. We need to, focus effort on this aspect of human existence to develop our space infrastructure and to expand our civilization into space. But yeah, yet major space exploration and research players have historically dismissed these piecemeal calls to action, often aggressively and even derisively, saying they're irrelevant. It's not irrelevant. I think that's the realization that we're all having now. Change is happening, Santaguida told Mike. Change that happens, change that might open avenues for a fleshed-out proposal like her team's to attract concentrated support and gain some traction with space agencies as well as private industry players. So yeah, change is happening. That's basically the gist of the news here. Is that in like NASA and SpaceX, they are starting to change. But let's get into the details here. So, ever since the early days of human space exploration, we've recognized that low gravity, high radiation, all this stuff has had profound effects on the human body. From the muscular system, the cardiovascular system, to the eyes and the nervous system, to our DNA. But we haven't really studied sex in space. And usually this has been like a logistical issue. These early missions were they were short, they were cramped. There wasn't really an opportunity for people to have sex, even if they did spontaneously develop a romantic relationship. Now, NASA says that they're mostly focused on astronaut health and safety, first and foremost. But in the 80s, during the space race, the Soviet Union launched Mir, which was the first space station. It was this big, roomy spacecraft that had co-ed crews. And one of the things that the public started talking about, like immediately, was you got all these co-ed crews in this big, basically dorm room in orbit. Are they going to have sex? Are they going to bang? Is that happening? Let's say here, what would it be like? Would it even be safe? We don't know. There's been no research. But it's become a really popular subject. People want to know how this might work in space. Everything from romantic attraction to the act of sex itself to the health of, gestation and raising a child. What's frustrating, though, is that all of this reasoning has just been called professional carping by biologists. NASA has dismissed it as professional carping by biologists, as a big stink over nothing. And that's just, it's frustrating, because it's obviously not. And eventually, NASA changed its tune. So while writing this article, Mike was able to get into contact with NASA representatives, and they explained that the NASA rep explained that when they did kind of realize that, okay, maybe this is something that we really should invest resources in, they started studying the reproductive physiology, so like the gametes and the gonads of like fruit flies and worms and snails and jellyfish and fish, frogs and chicken eggs and rodents, and they also did studies with bull and human sperm. But unfortunately, despite this rather eclectic approach to studying reproductive physiology in space, there was a review study published in 2018 by Alex Leyendecker and Shauna Pendaya, where they basically found that a lot of these animal experiments, a lot of these reproductive health experiments, had inconsistent and conflicting data, and there wasn't enough data to really come to any meaningful conclusions. So a lot of this research that's been done so far is like super limited in value. It doesn't really give us a lot of a lot of, actionable intel. So Chris Lenhart here is a space medicine expert who was interviewed by the National Geographic in 2018. And he said, if you were to take reproduction and break it down into all of its various parts, there's never really been a dedicated scientific program that looked at how each of these steps is affected. So like I was saying earlier, the romantic process, the attraction, in humans, this might be, not affected by space, the attraction aspect of it. But like, say you're an animal that has like a pheromone or a mating dance or something, if that's affected by higher radiation or microgravity, that could affect your ability to attract a mate, and that could have consequences if we're trying to recreate biomes in like orbital stations or on colonies on other planets. But also like the act of sex itself, conception and gestation, which I say here. We can only hazard sporadic guesses at the effect of the space environment on these processes. The lead author of that sex proposal, and another professional that they cite in the study a lot, or in this article a lot, is Simon Dubé. And he argued that research on human intimacy and sexuality in space, including their socio-cultural and psychological components, is quasi-non-existent. No research has explored intimate relationships, nor the human experience of sexual functions and well-being in space or space analogs, or how any of this can affect crew performance. So there you go. Like, they're saying, like, look, all this stuff that we've done or like put, token effort into doing, it hasn't given us any useful information. And we need to know this information. So why don't space agencies want to talk about sex? That's the big question. If people are, realizing that all this stuff is important, we have to know this information, why are we doing so little research? Why are we dragging our feet, basically? And well, here, the NASA representative in their interview with Mike suggested that they're really focusing on health and safety. Their astronauts have abstinence missions. They're trying not to prioritize sex because they're focusing on more like mundane, traditional things. Like here, they say ensuring crew members' health and safety for long periods of time. So they're more focused on like the basic physiological safety, sustenance, maintenance of the astronauts, not like any emotional or sexual needs that they might have as, human beings. And this is a big issue because they're planning, Project Artemis is a plan. It's a plan that NASA has in the works to create a permanent base on the moon that can act as a rendezvous point for trips to Mars. And all of this stuff, the permanent base, the trips to Mars, any base we build on Mars, is going to involve people living in space for months, if not years. Years. Do you want your astronauts to go years without sex? Do you think that might affect their performance? Because I do. I think people who are absent that long kind of, I don't want to say they go crazy, but their ability to socialize and cooperate with other people can become compromised. Relationships can be a bit strained if people are stressed and they haven't had release in a while. We see this all the time in our day-to-day lives. It's not going to be any different in space. But a lot of these excuses that the NASA rep is giving here, they're pretty, like, it's hard to argue with them because they're like technical issues, like, the size of the compartments and the logistics of it, and but there's a more realistic explanation that actually really kind of gets to the heart of the issue, and that's that the people who hold the purse strings for NASA's budget, they're a bit conservative, and they don't like taxpayer money going to studying sex in space. So this is why NASA has generally been kind of arm's length, hands off, with a unofficial abstinence policy. We're a group of professionals. We treat each other with respect, and we have a great working relationship. Personal relationships are not ... an issue. We don't have them, and we don't, says NASA's Alan Poindexter back in 2010. And then, Valery Polyakov, a Russian cosmonaut who spent well over a year in space in the 90s, he had a diary, and he noted that state psychologists, and I think this might have been post USSR, so this might have been the proto-Russian Federation at the time. But whoever the authority figure was at the time, they supplied him with psychologists who recommended that he take a sex doll or some dirty movies up there to help him with any urges. But he said that he just ignored his sexual urges, and after a while they just faded. So apparently it wasn't really an issue for him. But I don't know if that's a reliable method that you could expect out of every astronaut on a permanent base or something like that. This is an important point here. In a 2020 policy memo, Seth Barbro of the Military Academy wrote, "Although astronauts are held as professionals, long-term missions beginning at 2.5 years open possibilities for conception." In other words, if you have people living in a close quarters, like a spaceship, an orbital station, a moon colony, a Mars colony, for 2.5 years or more, that's enough time that they'll develop a close enough social relationship that even if they're trying to be professionals, that might get down. Sometimes, you got that tension at work, sexual tension, and if you're on another planet and your boss, is millions of miles that way, I mean, you're probably gonna have sex. I think it's a bit naive and unrealistic to think that you wouldn't. But agency critics often argue that this is not pure naivete. Willful sexual ignorance, after all, is out of character for a group of serious scientists. Exactly. So a lot of these technical excuses that they're giving for why they're not really studying too much of sex and space, they don't really explain it. It's not the full truth. I think the full truth is revealed in incidents like the Voyager probe, which they mention here. So the Voyager probe included a golden plaque that had a bunch of information about our solar system and humans, so that it is more of a symbolic thing, really. But theoretically, if any aliens were to find the probe and look at it, they could learn about us. And hey, these organisms live on this planet and this star system, and that's what they look like. That's kind of cool. And so there was a depiction of a male and female human naked. And you'd be surprised the amount of controversy that went into determining the level of detail on each of these nude figures. For example, the so-called cleft of Venus and the female genitals was censored because it was determined to be too obscene. And you had some conservative senators in Congress who didn't want to fund this. They didn't want to approve a mission that would, in their words, be sending porn into space. I mean, this is really silly because we're sending a probe into space where it's going to travel for, who knows how many millions, billions of years before it runs into a star or something. The chances of it actually being found by an alien who looks at it, realizes what they're looking at, perceives it as some kind of pornographic material, and then gets offended. Like, it's such a goofy scenario that you almost have to stand in awe that a congressman in an actual country would seriously make this point. I mean, it's just so silly. But a space artist, John Lomberg, who worked on the Voyager probe, said, quote, "All it takes is one member of Congress complaining about smut to torpedo future funding." Why would NASA risk it? Now, the reasoning there, behind the congressman's reasoning, makes no sense at all and is completely indefensible and stupid, but they're still a congressman. They're an elected official with control over the budget, and NASA has to play ball. They don't really have a choice in that regard. And that's a super big bummer. But it seems like things are changing for the better, which is good. But another bad thing, I know this is kind of like a roller coaster. We're on an emotional roller coaster right now. But another downside is that the free market has kind of failed in this regard. Where NASA and state space agencies are a bit hesitant to talk about sex in space, you would think maybe private space organizations with their own funding that aren't beholden to, conservative congressmen and conservative electorates with puritanical values towards sex, you would think that they're not constrained by that, so why don't they research sex in space? But they're not doing it either. And in many cases, their reasoning is even worse. So Elon Musk, for example, notably brushed off concerns about the effects of space on any aspect of human biology, arguing that his job is just to work out the hardware of how to get to Mars cheaply, quickly, and reliably. So this is an example of engineering brain that I've noticed. As a biologist, talking to engineers, they're often, wonderful, brilliant people, but they can often be myopically focused on the hardware, on the engineering component of it, without realizing that the engineering necessarily has to take into consideration biological aspects of, the humans who are using this hardware. It's like you wouldn't build a ship, like a cargo ship, without bathrooms for the crew, right? Same issue here. Like it's like Elon thinks he's just building a tube to get people to Mars. But it's like, if you don't take into account people's like emotional and psychological health, your crew is going to go crazy and they're not going to be able to complete their mission. Like, if you want your crew to land and set up a permanent colony on Mars, like Musk wants to do, he wants to colonize Mars. But if he's not concerned about the effects of the space environment on the bodies of his crew, how can he expect this mission to be safe? How can he expect his crew to be safe and to be able to function adequately to perform their mission if their emotional and sexual health, especially for long-distance multi-year missions, is being totally ignored? It makes no sense. It's super risky. And then you think that's bad. Like, holy shit. This Mars One, the defunct organization that planned to settle Mars, also waved away questions about sex. And oh my god, you guys, this should be a fucking crime. Listen to what they're saying. Mars One said that they would give every settler ample contraception, tell them about the known risks of space environments for sex, reproductive health, and child development, and see what happened. Okay, so there's a reason that ethics is like a really big part of like biological science and like medicine and like like clinical trials and stuff like this. If you're testing a drug in a clinical trial and it starts to have like maybe there's no effect, or maybe it has maybe there's no effect and some other drug you're also testing starts to show a really good effect, well, ethically you would actually stop that trial with the drug that has no effect and put those patients on the drug that has an effect, because otherwise you're going to keep them on a drug that your preliminary data says isn't working and they're going to die when something else that you have data that says works is available but you're not giving it to them. That's not ethical. Now, when you're talking about colonizing space, if you're doing it the Mars One strategy, like they explained here, not ethical. So you can tell your crew about the risks of space. Okay, they have that information, but if they're still going out in space, having that information isn't going to protect them because they're actually out in space. They're exposed to the radiation. They're exposed to the microgravity. If they're on Mars, the surface of Mars has perchlorates in the soil. It's got sterilizing levels of radiation because of the thin atmosphere. There's all these like really dangerous variables that could affect the health of the crew, and that could affect their reproductive health, and that could affect child development. And Mars One is just not taking really any serious precautions. It's like, okay, let's go colonize Mars. On the way there, you're going to be exposed to a lot of radiation. Here's some contraception so you don't have, mutant Mars babies. But if you want to, nothing's going to stop you. I mean, nothing that they mentioned here indicates any kind of regulation or any kind of like monitoring or anything whatsoever. So Mars One, thank God it's defunct, but they were on path to make, mutant Mars babies with sperm and eggs from astronauts that have spent months traveling through space. So all the DNA in their gonads has been rattled and mutated to who knows what extent. And Mars One is like, let's just see what happens. This is a fucking nightmare. Like, thank God they never got off the ground with this, because I mean, they would have to censor all of the information coming back from their Mars colony because it would be absolutely horrific. I mean, it's just appalling. And so Chris Lenhart, that space medicine expert, is corroborating this point. He's saying, quote, everyone is focused on the hardware. And the hardware is great, but in the end, it's the squishy meat sack that messes everything up. Ignoring the human system, if you will, in future plans and designs is only going to lead to failure, no matter how impressive a firm's hardware may be. Exactly. That's the point I'm making. Academics, or either independent or ensconced universities, also tend to have more freedom to explore subjects that the big space agencies might not want or to be able to themselves, but they lack resources. Exactly. So the people that want to research this stuff often don't have access to the space programs or the resources within the space program. And so basically, the space sexology proposal was like, it's like the tip of the spear of this big, growing cultural momentum that's been, rising and gaining strength for literally decades, as people have been saying, with louder and louder voices, we have to study this, we have to study this, we have to study this. And now, Judith Lapierre, a health expert at the Université Laval and one of the co-authors of this sexology proposal, said, quote, we need to bring everyone to the table to holistically address the transdisciplinary challenges of human eroticism in space and facilitate well-being as we journey to the final frontier. It's rather, waxing poetic there a little bit, but I totally agree. I mean, we absolutely need to learn more about this before we develop space infrastructure and send people out into space more. One of the authors, Simon Dubé, said, quote, there has been great positive interest in our proposal from the media, the public, and some people working in the space sector. We hope to leverage this interest to make innovative collaborations and science happen in the near future. And so the article concludes by saying that, quote, this may sound like the unduly optimistic platitudes of activists, but there are faint signs that the team may be onto something. Notably, NASA seems far more receptive to questions about sex and intimacy in space than they have been in the past, when they might have just ignored queries like Mike's. There's also some paper trail evidence, and this is the important part. There's some paper trail evidence that people within NASA are trying to push the agency to funnel money into ambitious new sexual health projects. There you go. So that paper trail of evidence suggesting that money is being focused into these projects, that's some pretty good news. I mean, that means that inside NASA, gears are turning, the ball is rolling, things are getting off the ground here. So this is really cool. Lapierre adds that as humans push into space, quote, it would be nothing short of unethical to let these roadblocks stand in the way of knowledge, unquote. Yeah, and I agree. It is unethical to not study sex in space, especially as we start developing more space infrastructure and we have more, we have plans for permanent bases and long duration missions. All of this stuff is going to need us to refocus some of our priorities and try to recognize the importance, the necessity of sexual health in space. And as we develop, permanent colonies on the moon and Mars, we start raising kids here. That's going to happen. It's going to happen within the next, 1 or 2 centuries. At the rate we're going, unless human civilization gets wiped out by nuclear warfare or climate change or something. Unless something like that happens, we're on track to start being a true interplanetary species, having children and raising them on other worlds. And before we do that, we need to understand what the health effects are going to be. We need to start researching this. And it looks like, thanks in large part to this space sexology proposal, that's beginning to happen. So I just want to wrap this up on a philosophical note. I think that this whole issue, it's really interesting, not just from a scientific perspective, but also from like a existential, philosophical perspective. The fact that we're studying sex in space and romance in space and all of that, it's because these things are very soon going to become a reality as humans engage in this multi-century project to become an interstellar, I'm getting ahead of myself. Not an interstellar, but an interplanetary species. This research is a critical part of that. So it's super valuable, super cool stuff. All right, well that's basically it for the science news stories that I had for you today. If you thought this video format was awesome, let me know in the comments, and I'll try and do stuff like this again more often. See you later, guys.